Hi, everyone. Thanks for showing up for your learning. We're going to take a look at problem type 3, factoring trinomials and special cases of factoring some difference of square binomials here. I ran out of my normal half caffeine coffee. I'm on to full caffeine coffee today. So if I'm extra hilarious, maybe blame the coffee. Let's go, everyone. So I've got my problems here. I'm ready to factor them here. Note that even math teachers, we make mistakes too. There's a mistake in here. Should be a 3, okay? Which I've mentioned that many times in class. If you don't listen to me in class, it's your own fault for not listening and being frustrated. This one doesn't factor. I'm not very good at this. No, you're good at this. It doesn't factor if it's a 5. So in this case, we have an a value that's 1. A equals 1. That's a special case that's much easier to work on. So all we need to do is win an x game with minus 40 in the top. We want numbers that multiply to minus 40 and add to minus 3, this number. Multiply to c and add to b. Okay, numbers that multiply to minus 40, well, I can see that minus 8 times 5 would fit the bill. Maybe you don't see that, and this is what I recommend you do. You get some scrap paper. Do I have some scrap paper available right now? Oh no, but I can open some. I have an infinite digital paper here on my blank pages. Okay, so here we go. So woo, I got some blank pages here. And then what you do is you take minus 40, this number, and create a factor tree. I notice that minus 40 is divisible. Maybe you notice it's divisible by 10. Sure, take out the 10. It's 10 times 4 times negative 1. You can put that negative 1 there for negative numbers and just know that that's like one of its factors. 10 and 4, okay, so I noticed that those are still not prime. 10 is divisible by 2, so it's 2, that's prime, circle it, and 5. So 10 divides into those two things, and they're both prime. 4 divides into 2 and 2. Okay, and this gives you a list of factors that you can mash together in different ways. Let's try mashing them one way. 2 multiplied by the rest. 2 times 5 times 2, that would be 20. 2 times 20, but let's make the 20 negative. Okay, that would be negative 40. This is multiplying to the right number. Remember, this is the x game we're playing right now. Multiply to minus 40 and add to minus 3. Okay, but oh darn, these add together to minus 18. I want factors that have a much smaller difference. I want factors that are closer together. So instead of grouping only one of these 2's on its own, let's put two 2's together. All right, and we'll make it 4 plus negative 10. Well, that's close. I got to negative 6, but I want negative 3. So I want even a closer difference. So let's try all the 2's together. 8 times minus 5 would give me minus 40, but that adds together to give me 3. Oh, darn, I want a negative 3. So flip the signs. Negative 8 plus 5. There's my minus 3. Just go through the different possibilities of grouping these factors together in different ways to create different numbers. 2 times 20 didn't do it. So then we tried 4 times 10. That didn't do it. Then we tried 8. Okay, you get the idea. All right, it's really gross. But anyway, so then once we've got those numbers, negative 8 and 5, all we need to do is plop those into the brackets with x. That only works when a is 1, x plus 5. There's other ways to do it where it will work when a is 1 and when a is not 1. And I want you to do it the fast way, not the slow way. So I want you to do the special cases this way. If you have a different way that works, keep doing it your way. All right, g of x is negative 2x squared minus 4x minus 2. Here we've got an a. A is not equal to 1. I don't know if you know, but negative 2 is not 1. Okay? And first step that you're always going to do is check for common factors. And there is one. It's minus 2. So g of x is equal to, let's factor out that minus 2 from everything. So if I divide this term by minus 2, I just get x squared. This term by minus 2, I get plus 2x. And this term by minus 2, I get plus 1. Okay. Notice that if I then used the distributive property to undo what I just did, I would get this line exactly again. And that's your error checking. You're always kind of checking to the back line to make sure that what you just did you could undo and you wouldn't have changed things. Okay, so that's g of x. And now I'm looking for numbers that win this x game for me. They should multiply to 1 and add to 2. Okay, this number here, multiply to 1, add to 2, because now a is 1 in this point here. Okay, so now I can win the special x game. Those numbers are 1 and 1. Oh, cool. 1 times 1 is 1. 1 plus 1 is 2. Isn't that cool? So g of x is equal to negative 2 times x plus 1. Just plop those things into the brackets with x plus 1. All right. And then we might also get fancy and say, well, that's a negative 2 times x plus 1 squared. Ah, cool. This is now a vertex form parabola. It's factored form and vertex form right there. Cool, eh? Sometimes when you factor, you can get to vertex form. All right. But with h of x, okay, let's take a look at h of x. Maybe I need to do this one on my blank pages over here. So let's see. 3x squared plus 13x minus 10. Let's do this down here away from all of that weird factor banana. H of x is equal to 3x squared plus, I think it was 13x minus 10. Is that correct? Yes. All right. So copy carefully. All right. And now I notice that 3 is not a common factor here. I'm not able to simplify this by common factoring. I now have to factor when a is not 1, and these are more challenging. The way we do it is we win a special x game where we take a times c, in this case, 3 times negative 10 or negative 30, and we want to multiply to negative 30 and add to the b value here. This is just the b value of 13. Okay, so let's find numbers that multiply to negative 30 and add to 13. Those numbers are 15 and negative 2. Okay, and you can use factor trees to hunt for these numbers. All right, you'll notice that negative 30, it factor trees into negative 1. That's kind of, it's not prime, but it's kind of primey thing. And then 30 is divisible by 2, and we get 15, and we might notice it right there. You might notice, oh, if I had negative 2 and 15, that would add to 13. Great. If you don't notice it, you're going to break this down into 3 and 5 and only have a few combinations to check. Maybe you check 6 and negative 5, and that adds to 1, and that's not 13. You want a bigger difference. So then you might check 10 and 3, 10 and negative 3, and then that would be negative 7. Or sorry, that would be positive 7. You still want a bigger difference, so then you check 15 and 2, and you'd get it. Okay, so you just look at all the possibilities of multiplying those numbers together to make negative 30. Okay, now what do we do with this number and this number in this case when a is not 1? We break that middle term down. H of x is equal to 3x squared plus 15x minus 2x minus 10. And here I chose to put the 15 next to the 3 because I see they share a factor 3, and the negative 2 by the negative 10 because they share a factor negative 2. So just simplifies my work in the next step. So now we're going to factor by grouping. We group these two together, and we group these two together along with their signs. Okay, and so you're going to common factor both of those pieces. So I'm going to do the first piece here, 3x plus 15x. I see the biggest common factor is 3x. And then I would multiply 3x by x plus 5. Notice if I use the distributive property, it recreates these two terms here. Okay, so that's how I check my work constantly to avoid making errors. And then let's common factor this one over here. I'll do it in purple. My colors are shifting a bit, but negative 2x minus 10. My biggest common factor is minus 2. If it's plus, write a plus there. If it's minus, write a minus there. And then we're going to multiply that by x plus 5 to recreate those two terms. Okay, and notice that the same binomial factor showed up two places at once. So our next line is to factor that out, x plus 5. And then what's left? Well, I need to multiply x plus 5 by 3x minus 2. So put that into the next brackets, 3x minus 2. And that's how you factor those ones. Okay, that's done. That's basically factored form. I'm not going to confuse anyone, so I'm not going to put it in fully factored form. So just copy that onto show the steps on your test, please. This was, copy it out carefully. 3x minus 2 multiplied by x plus 5. Cool. And then we multiply this here, and this here, and this here, and this here. And you'll find that when you FOIL that, you will get exactly that back. That's how you know it's the correct answer. Okay, let's actually check our answers here, because you should check your answers on the test because you care about your marks. 3x squared plus 15x minus 2x. Notice that's how we broke that down into factors. And minus 2 times 5 is minus 10. If I simplify this, I get this back. Cool. Cool, cool, cool. All right. X squared minus 81. Oh, no spare paper here needed. I just need to notice that this is a case of a squared minus b squared, which always factors into a plus b times a minus b. No time for explanations here. Just remember the pattern. If you're just looking at this, just notice that this is a square, that's a square, and it factors this way. So let's take a look at what we do. We take the square root of x squared, which is x, put it in the front of the brackets, have a plus and a minus. Doesn't matter where they are, just one's plus, one's minus. And the square root of 81 is 9. 9 squared equals 81, right? So x plus 9, x minus 9. Done. It's just that easy. But you have to be able to recognize them. And on the test, they're easy to recognize because there's only two things. Down here, oh, look, k of x. There's only two things. I bet it's one of these. Oh, wait, I recognize that 25 is a square and 9 is a square. So that must be that, right? It must be a difference of squares. So let's do it. 5x multiplied by 5x would give me 25x squared. And 5x, so we put that in the front of the brackets, plus, minus, and then the square root of 9. 3 squared equals 9. And 5x times 5x is 25x squared. So this is how I know what to put in the brackets. Okay, done. That's it. Questions about this stuff, absolutely send me an email, but the explanations are in other videos. So this is quick and dirty. All right, m of x. Ooh, it's a cubic. It has an x cubed term. Oh, a is not 1. This is going to be really hard to factor. I'm going to have to wait until grade 12 to factor this. No, you don't. You simplify this with common factoring. I notice that x is common to all the terms. The smallest one is just x to the 1, just a single x. So I can factor that out in front. And I also notice that 2, 28, and 66 are all divisible by 2. So my greatest common factor is 2x. So let's take out 2x. If I multiply 2x by x squared, that would recreate this. If I multiply 2x by 14, that's a strange way to write 14, 14x, that would recreate that. Notice 2 times 14 is 28, and x times x is x squared. So I'm checking my work as I go. And then I divide 66x by 2x, and that's plus 33. Done. 2x times 33 is 66x. Okay, so it checks out with distributive property. Now I check and see, can I multiply to 33 and add to 14? Oh, geez, 33 is a big number. I better get a factor tree going here. 33. Is it divisible by 2? No. Is it divisible by 3? Yes. 3 and divides out 11. 3 and 11 are prime, and 3 plus 11 is 14. Wow, we solved it, everyone. We solved it. Pat yourself on the back when you solve hard questions like this. 2x multiplied by x in the brackets, x in the brackets, plus 3 plus 11, done. If you expand that, you will find it's exactly this. We haven't changed anything. We just rewrote it in its factored form. This is the main skill of this unit, is factoring. So we wanted to get a lot of practice, and you can expect more questions than usual on a single topic on this test. Like, for example, 6 questions, maybe 4. Depends on how much extra time that I want to give you all. Okay, everyone. Thanks very much for showing up for your learning and for tolerating me in my highly caffeinated state. Anyone who got this far in this video should send me the code word. We've done big birds already. Let's do albatross, one of the biggest birds. All right, send me the email albatross, and I'll know you got all the way to the end of this video. Bye. Oh, and email me your questions too.